Okay, Assalamualaikum and good morning, everyone. So today we are going to discuss your quiz number 10, and also we are learning. We are going to learn chapter 4B. Okay. So for quiz number 10, quiz number 10, question number 2. The question number 2 is the same as in the slide. So I want you to marks yourself for question number 2. Okay, because it's already in the slide. So for today, we will discuss question number 1. Okay, so for question number 1, because I already lay out the steps to answer, so just follow the steps. Okay, so for question number 1, the first step is to substitute the value of S in Fs. Okay, so Fs equals S plus 2 times S plus 4 divided by S times S plus 3 S plus 6. Okay, so first step is you need to substitute the value of S. So S is minus 7 plus 9j. So just substitute. So Fs equals minus 5 plus 9j minus 3 plus 9j minus 7 plus 9j minus 4 plus 9j and lastly minus 1 plus 9j. Okay, so the next step is calculate the magnitude and angle for each pole and 0. Okay, so now after you substitute S, then you need to find the pole and 0. So here the numerator and denominator are already factorized. Okay, so you don't need to worry much, meaning that you just take the value in each of the bracket as your pole and 0. So maybe we can start with the numerator. Numerator means you find the 0 first. Okay, so these are the 0 and these are the poles. Okay. Okay, so we start with the first 0. So that says 0 number 1 is minus 5 plus 9j. So if you plot in the S-plane, it will be somewhere here. Okay, so the magnitude M1 is square root square root 25 plus 81. So you get square root 106. And then theta 1 is 180 degree minus tangent minus 1 9/5. And then for 0 number 2 is minus 3 plus 9j. So calculate the same thing. So M2 is square root 9 plus 81 square root 90. And theta 2 is 180 minus tangent minus 1, 9/3. Okay, so we have settled for 0. Now we continue for the poles. So poles number 1 is -7 plus 9j. So magnitude 49 plus 81. So you get square root 130. And angle 180 minus tangent minus 1, 9/7. And then poles number 2. Square root 16 plus 81. So you get square root 97. Oh, silap. So tangent minus 1, 9/4. And lastly, okay, so when you found every magnitude and angle for each pole and 0, then you can use the find number 3, the formula number 3 and 4. So to find the total magnitude, so you need to use the product of zeros divided by the product of poles, and to find the angle, use sum of zeros minus sum of poles. So the total magnitude M is M1 times M2 divided by M3 times M4 times M5. Okay, and then for angle, it's theta 1 plus theta 2 minus theta 3 plus theta 4 plus theta 5. Okay, so pandai-pandai dalam marking 4 markah. So 4 markah, so whatever answer you get for M is 2 marks and theta 2 marks. Okay. Okay, so question number 2 is on your slide. So you just refer in the slide and mark yourself. Okay. So saya rasa semua orang pun mungkin refer slide masa buat question number 2. So you should get the same answer with the slide. Okay. Okay, so we can go to the next lecture. Okay, so we have 2 more slides on root locus. So we have slide 4B. So 4B is the notes for root locus. And if you look at column, you also have slide 4C. So 4C basically contains example, okay? Example on the root locus, how to calculate and how to plot, how to sketch root locus. So maybe what I will do is I will teach you the theory, and then I will go to slide 4C to show you the example. Okay, so let's continue with lecture chapter 4B, refining root locus. refining root locus sketch. So students will be able to apply additional rules for refining root locus. So by finding the real axis breakaway break-in points, finding JW axis crossing, and finding the angle of arrival and departure. Okay, so I will explain what are these later. So let's review what is root locus. So root locus is the path or the graph of the roots of the characteristic equation, or the path of the poles, the roots of denominator traced out in the S-plane as a system parameter is changed. So when you find the roots of denominator and you plot in the S-plane, as you change the value of k, then you will get the root locus. So root locus, basically the plot of the poles when you change or vary the value of gain k. Okay. So compared to route Hurwitz, so route Hurwitz, basically you want to find the range of k for stability. And meanwhile, for root locus, you plot for different value of poles when you vary the value of k. Okay, so there are differences between root locus and route Hurwitz. So maybe later on you guys might confuse why we need to use root locus, why we need to use route Hurwitz. So as we learn, maybe you guys will maybe clear a little bit why they are different. Okay. So this is an example. So let's say you are given a system with a gain k and a forward transfer function gs and feedback transfer function or backward transfer function hs. Okay, so the first step you need to do is you simplify the block diagram by finding the closed loop transfer function. So TS here usually represent the closed loop transfer function, meaning that you simplify the block diagram. Okay, so the denominator, the bottom one here, so we get 1 plus k times s plus 1 times s plus 3 divided by s plus 4 times s plus 5 times s plus 2. So the denominator becomes the characteristic equation of the transfer function. So when you simplify the denominator, you get something like this. So we want, basically in root locus, we want to plot the value of poles from k equals 0 until k equals infinity. So the root locus starts from the value of poles at k equals 0 and finish at the value of poles at k equals infinity. So always remember that the root locus starts from k equals 0 until k equals infinity. But the value of poles, okay, not the value of k. You plot the value of poles. So for example, just now, the transfer function just now, when k equals 0, so when k equals 0, if you look at this equation here, so when k equals 0, then this term is becomes 0, okay? Then you have your poles equals s equals -2, -4, and -5. So you have 3 poles when k equals 0. And you can plot, so you plot poles using symbol cross, okay? So you plot the poles at -5, -4, and -2. Okay, and then the next step is you find the value of the poles when k equals infinity. So when k equals infinity, basically you find the poles at so when k equals infinity, so s equals -1 and -3. -1, -3. Okay, because this the contribution of this part is bigger compared to this, so this you can practically ignore, okay? Theoretically ignore. So if you look at here, s equals -1 and -3, these are basically the zero of the transfer function. Okay, so when k equals infinity, then the poles that you find is actually zeros. Okay, zeros of the transfer function. So to plot zeros, so you use circle. Okay, so here the zeros is at -1 and -3. So -1 and -3. And usually for root locus, you must have the same amount of poles and zeros. So just now you have 3 poles and you have 2 zeros, which is -1 and -3. So because you have 3 poles and 2 zeros, so you need one more zero to make sure that you have the same number of poles and zeros. So the extra zero that you add to the root locus, basically you add one more zero at infinity. Okay, so you have 3 poles at -5, -4, and -2, and 3 0 at -1, -3, and at infinity. Okay, so that's the basic idea of finding zero and poles to plot the root locus. Okay, so don't worry about the arrow here. Later we will see what are they. Okay, so there are, I think, 9 rules for sketching the root locus. Okay, so let's look at the rule number 1. So the number of branches of the root locus equals the number of closed loop poles. So just now you have 3 poles. So your root locus, you must expect that your root locus to have 3 branches, okay? Because you have 3 poles. Okay, so the branches meaning that, for example, in this root locus, so this root locus, you have one branch here and another branch going upward. Okay, so you have 2 branch because this root locus you have 2 poles at here -10 and also at 0. Okay, so let's look at the previous example. So here in the previous example, because you have 3 poles, -5, -4, and -2. So you are going to expect that there are 3 branches. Okay, so the first branch is this red arrow here. The second one is this red arrow, and this is the third one. So there are 3 branch of the root locus. Okay, so always remember that the number of branches equals the number of poles or zero. So whichever the most. Okay, so let's say you have 4 zeros but 3 poles, so the branches is 4. The number of branch is 4. Okay. Okay, so the rule number 2. So the root locus is always symmetry about the real axis. So this is the same example. If you look at the root locus, it's symmetry about the x-axis, the real axis. So let's say if you have one branch, let's say, have this kind of shape, then the other branch should have the same shape but symmetry about the real axis. Okay, so you cannot have one branch maybe going down like this and the other maybe going up like this. No, this is wrong. So you must make sure that your root locus is symmetry about the x-axis. Okay, so this is important, okay, symmetry. And then rule number 3, so on the real axis, for k bigger than 0, the root locus exists to the left of an odd number of real axes, finite open loop poles or finite open loop zeros. Okay, so rule ni sampai sekarang saya pun tak tahu apa benda dia nak cakap. Basically what I understand on this is that the root locus always start from the poles and finishes at zeros, but it will always going to the left. Okay, so let's say if you start your root locus from this pole here, so it will always going to the left. Okay, jarang di going to the right. Okay, so for rule number 3, usually we will ignore ada certain cases je rule number 3 ni terpakai. Maksudnya akan make sense, okay? Akan make sense rule number 3 ni. Most of the time dia punya definition tu macam tak masuk akal. So kita skip, okay? Skip the rule, okay? Just take it by heart, okay? Rule number 4, the root locus begin at the finite and infinite poles and ends at finite and infinite zero. So meaning that your root locus always start at zeros and finishes at start at pole, finish at zeros. Okay, so if you have this poles, let's say poles at -1, -2, -3 and -4, so you are going to expect that your root locus to have 2 branches because you have 2 poles, and it will always start from zero, from the pole. So start dari pole. So macam mana nak pergi dekat zero ni, sebab zero kat sebelah sana. So you tak boleh bertindan macam ni. Nanti dia akan bertindan dengan this pole. Okay, so you tak boleh macam tu. So the only way that the root locus can be sketched is in the form of circle. Okay, so dia akan keluar. So another keluar satu lagi kat bawah. So dia akan keluar 2 sebab simetri dekat x-axis tadi. So dia tak boleh keluar satu je, dia kena keluar 2 lah sebab nak bagi dia simetri. Okay, so when it keluar, break away, okay, when it breaks away from the x-axis, then dia kena masuk balik ke x-axis. Okay, dia tak boleh break away dan break away terus sebab 0 berada di x-axis. So dia akan break away and then break in the x-axis, and then one of the branches will go to one of the 0 and another one will go to the other 0. Okay, so it will always start at pole and then finishes at the 0. Okay, so kalau let's say the question gives you only poles and 0 and ask you to sketch roughly, tak payah kira, so you kena guna intuition lah. Dia kena start from poles and finishes at 0, and then kena ada symmetry, kena ada the same number of branches with the poles, the number of poles. So now you maybe dapat idea sikit why the rules number 1 and 2 are important. Okay, so rule number 1, 2 and number 4, they are macam berkait rapat. Okay, so now rule number 5. So the root locus approaches a straight line as so the straight line we call it asymptotes. as the locus approaches infinity. Further, the equation of the asymptote is given by, so we have the real axis equals the sum of finite poles minus the sum of finite zero divided by the number of finite poles minus the number of finite zero. So this sum and this number, okay. And then the intercept angle, the angle of the root locus is 2k plus 1 times pi divided by the number of poles minus the number of zero. Okay, so here we have the word finite and infinite poles and zero. So finite poles ialah finite poles or zeros ialah the value of poles and zeros that you can directly determine from your transfer function. However, the infinite poles is the value of poles or zero that you add as an extra. Just now I explained when you have 3 poles and 2 zeros, so you need an extra zeros to make sure that the number of poles equals the number of zeros. So the extra that you add, which is at infinity, is called infinite poles and zeros. So finite poles and finite zeros are the poles and zeros that you can determine directly from the transfer function. Okay, so let's look at an example. So let's say you are given this this block diagram. Okay. Okay, so to find the poles for unity feedback, so this is unity feedback system. So for unity feedback system, to find the poles, the finite poles and finite zero, basically you can just use the forward transfer function. Okay, so the poles will be -3, -1, -2, and -4. And the zero will be -3. Okay, only for unity feedback. For non-unity feedback, you can simplify transfer function dulu. The simplify transfer function, then you need to assume at k equals 0 to get poles, at k equals infinity to get 0. Okay. Only for unity feedback, you can use the forward transfer function here directly to find the poles and zeros. Okay. So here, the sum of finite pole. So finite pole is -1 plus -2 plus -4. And finite zero is -3. So you get -4. And the number of poles, so you have, oh ada zero sini, sorry tak perasan. Okay, so 0. Okay, so number of poles is 4. Number of zero is 1. Okay, so 4 minus 1, you get 3. So the asymptote, the real axis intercept of the asymptote is at -4/3. So somewhere here, okay? Somewhere kat sini, in between -1 and -2. And then to find the angle, so because here you have the constant k here, so what you are going to do is you find the value of angle starting from k equals 0, k equals 1, 2, and so on, until your angle theta A, reaches 360 degree. So if your angle theta, when you calculate, you get more than 360, then you stop finding the angle. Okay. So for example here, so the first angle is at k equals 0, you get pi/3. At k equals 1, you get pi. At k equals 2, you get 5 pi/3. So all of these are still less than 360. So if you find at k equals 3, then theta A will be 7 pi/3. So 7 pi/3 is already more than 360 degree. Okay, so 360 degree equals 2 pi, okay? So if you get your value more than 2 pi, then you stop calculate, okay? Stop. Tak nak dah. Kita tak nak k equals 3. Kita nak until k equals 2 only. Okay, so you have three asymptote, okay? So one at this angle. So this angle is pi over 3. The other one is at this angle at pi, and another one is at this angle 5 pi over 3. Okay, so ada 3 asymptote. So the function of asymptote is that when you break away your root locus, so the root locus tak boleh cross this asymptote, tak boleh. So your root locus mesti menghampiri asymptote ni. Okay, approaching the asymptote, but it cannot cross the asymptote unless if your asymptote is on the x-axis. For example, this red line here. So kalau dekat x-axis, tak apa, dia nak cross pun. Okay, bukan macam ni lah bentuk dia. Bentuk dia basically starting from here to this 0 and starting from here to infinity. Okay, so the function of asymptote is that your root locus will never cross the asymptote, and it only approaching the asymptote only, okay? So that's the purpose of asymptote. Okay, so you have learned 5 rules. Okay, the 5 rules so far. So now let's look at the next rule. So we have 3 more rules. So we have breakaway and break-in points. Apa dia nombor 2 kalau dulu? Okay, so we have JW axis crossing. We have breakaway and break-in points. And lastly, we have angle of departure and arrival. So let's look at number 1 first. Okay, so the JW axis crossing is basically this point here. Okay, macam mana nak cari the JW axis crossing? So the JW axis crossing basically is the point that separates between stable and unstable system. So I think I've taught you that if your poles is on the left hand side, then your system is stable. However, if your poles is on the right hand side, then the system is unstable. However, if your poles is directly on the JW axis, then it's marginally stable. Okay, so basically, if you find the poles, so basically the JW axis crossing is the value of poles when the system is marginally stable. Okay, so it's the point that separates between stable and unstable system. Okay, so to find the JW axis crossing, so you need to use Rath-Hurwitz criteria. Okay, siapa yang tak erti buat Rath-Hurwitz criteria, sila fahamkan. Okay, sebab dia digunakan untuk finding JW axis crossing. Okay, let's look at an example. So let's say you are given this block diagram. So to find the JW axis crossing, you need to use Rath-Hurwitz criteria. So to use Rath-Hurwitz criteria, first step you need to do is you need to find the closed loop transfer function Ts. Okay, so you get this, the closed loop transfer function, and then you take the denominator. And then arrange in the Rath-Hurwitz table. So you use the denominator, start with S4, followed by S3, arrange the coefficient alternatingly, calculate S2, calculate S1, and calculate S0. Okay, so pure imaginary roots only exist when there is 0 row. Okay, maksudnya to find the JW axis crossing, you need to use the row that has all 0 in the row, okay? So only row S1 that the entire row can be 0, okay? So only this row can all be 0. Basically use row S1, okay? Teori detail dia kena baca. So basically you use row S1. So use row S1. So negative k squared minus 65k plus 720 equals 0. So use quadratic equation. You get k equals 9.65. So this is the value of k. So this is the value of k, okay, at JW crossing. And then you use this k, substitute on row S2. Okay, substitute in row S2 such that 90 minus k times S square plus 21 k times S0, okay, S power of 0. Okay, ikut je. Okay, dia punya teori kenapa kena guna S tu entah. Okay. Teori dia dalam buku ataupun dia boleh check kat wiki, tapi for the sake of nak ringkaskan supaya tak payah explain teori dia detail, dia macam ni je, okay. Use row S1, find the value of k. After that, take the value of k, use it on row S2. Macam ni, okay. Take the first column times S square plus the second column times S power of 0. Okay, so after you substitute the value of k, you will get this. And then from here, you find the value of S. So S equals 1.59 J plus minus. So this is the JW axis crossing. Okay. So dekat JW axis, the point is at 1.59. Okay, so at k equals 9.65, the system is marginally stable and oscillating at frequency 9.65 radian per second. Okay, ni salah. Okay, oscillating at S equal J omega equals 1.59 J plus minus. So frequency dia 1.59, okay, plus minus radian per second. Okay, so this is the frequency. Okay, so if you plot in the root locus, so the point here, as shown in the slide, is the JW axis crossing, and the value is 1.59 and minus 1.59, and the gain is at k equals 9.65. Okay, yang ni ni example macam mana nak buat dalam MATLAB, okay. So ni sesuai guna untuk project part 3. So basically dia tulis balik the transfer function, okay. So mungkin kalau nak untuk part 3 korang boleh cari apa maksud R locus, okay, for project part 3. So from there maybe you can understand more what is num and then here, and then you will get this plot. Okay. So the second rule is the real axis breakaway and breaking points. So for example, if you have this root locus, then you will see that there is a breakaway here and breaking point here. So macam mana nak cari point ni? So we have a formula. So the angle at breakaway or breaking point So the angle is 180 divided by n. So n is the number of closed loop poles arriving or departing. So here you have two poles that are departing. So 180 divided by 2. So the angle is 90 degree. So angle ni selalu tak tanya pun, okay? Angle untuk breakaway and break-in. And to find the real axis breakaway and break-in points, so you have two methods, differentiation method and transition method. So differentiation method kita tak ajar, but you can find it in Google, okay? So we use transition method. Sama je, okay? You will get the same answer. So the transition method is, this is the formula. So the sum of 1 divided by sigma minus 0 equals the sum of 1 divided by sigma minus pole. Okay, let's look at example. Okay, so let's say this is the root locus. Let's say kita tak tahu breakaway and break-in point. So from this root locus, your poles is these two. So S at -1 and -2, and zeros are these two, okay? So zeros is at 3 and 5. So to use this formula, basically the 0 is 3 and 5. So you sum, okay? 1 over sigma minus 3 plus 1 over sigma minus 5 equals 1 over sigma minus 1 plus 1 over sigma minus 2. Simplify, sebab online korang gunalah simbol lab. Okay, janganlah lembab sangat gitu. Okay, janganlah buat manual. Ada simbol lab, guna simbol lab. Okay, online. Okay, I think all lecturers are expecting you guys to use some sort of software to calculate. Okay, so don't worry. Okay, dah online guna je simbol lab. Okay, tapi jangan beritahu student lain, Sir Jamil cakap guna simbol lab. Okay, jangan cakap lecturer lain suruh guna, bukan Sir Jamil. Okay, so use symbol lab, you will get 11 sigma squared minus 26 sigma minus 61 equals 0. Use quadratic equation, so you get sigma equals negative 1.45 and sigma equals 3.82. Okay, so you have two sigma here. So one sigma represent this point, negative 1.45. The other one is here, 3.82. Okay, so ada 2 point. Okay, sometimes when you calculate breakaway and break-in points, you might get additional sigma. Okay, maybe ada terlebih sigma. Okay, nanti kita akan tengok dalam example. Maybe tak sempat hari ni. Okay, when you have additional sigma, you need to use again your intuition lagi sekali. Sigma mana yang tak perlu pakai, okay? Yang tu memang kena fikir lah, okay? Yang tu tak boleh nak ajar, tak tahu macam nak ajar. Kena by experience kot. Okay, lastly, the angles of departure and arrival. Okay, so the angle of departure and arrival, this is the formula, okay? So the first step you need to do is you plot all the poles and zeros. Okay, so the first step is plot poles and zeros. After that, you find the angle for each pole and zero. So the angle from for each pole and zero made from other poles and zeros. Okay, so for example, this angle, let's say this Okay, yang ni. Okay, kita ambil ni. This 0 here. To find the angle of departure for this 0 here, basically you need to find the angle made by the other 0 and pole to this 0, okay? So you need to find the angle here, this angle, and this angle, and also this angle that made to this 0. Okay, let's look at example ada tak? Okay, so in this example, find the angle of departure from the complex poles. Okay, so one more thing about angle of departure and arrival. So angle of departure is for complex poles. Meanwhile, the angle of arrival is for complex zero. Complex maksudnya bila you dapat poles equals maybe 1 plus 3j for example. So kalau ada bentuk macam ni, this is a complex pole, okay? So angle of departure only for complex poles and angle of arrival only for complex zero, okay? Kalau tak ada complex, tak ada angle of departure and arrival. Okay, tak payah cari. Okay, so from this example, the first step you need to do is find the poles. So poles is at -3 and -1 plus j and -1 minus j. Basically, factorize yang equation ni. Okay, so the zeros are -2. So ada 3 poles and 1 zero. So you need to add extra 0 to make sure that the number of 0 equals the number of poles. So -2 and infinity and infinity. So here you have complex poles. Tetapi 0 tak ada complex, okay? Only a real number. So dekat sini hanya ada satu angle sajalah. Angle of departure, angle of arrival tak ada. Okay, so yang ni dia ajar terus teori root, macam nak plot root locus, okay. So rule number 1, we must have 3 branch. So ada 3 branch sebab ada 3 poles. And rule number 2, it must be symmetry about the real axis. And number 3, start from odd poles or zeros to the left of real axis. And rule number 4, start from pole to 0, okay. So you use all the 4 rules. Okay, so to find the angle of departure, so first step is plot the poles and 0 in the S-plane. Okay, so the angle of departure only exists on the complex pole. So this is the complex pole just now. So you find the angle made by the other poles and 0 to the point, okay. So the first 0, the first angle is made by this pole here. So this angle, so theta 2 is directly below this pole. So the angle is always 90 degree, okay. Tak payah kira lah. So theta 3 is made by this 0 here. So you need to use the tangent formula. So theta 3 equals tangent minus 1. Tinggi ni, which is 1 divided by panjang ni, minus 2. Okay. Or 2, okay. And then theta 4 also use tangent, tangent minus 1. 1 divided by 3. Okay, so the step is plot the poles and 0 and then find the angle made by the other poles and 0, okay. And then use the formula. So you will get the angle is at 108.4. So the angle is this angle that you want to find. Okay, so meaning that your root locus, dia nak keluar dari pole ni, dia akan keluar ikut this angle. Okay, baru dia keluar macam tu. And because this pole here is symmetry, and the root locus must be symmetry, so you don't have to find the angle for this pole. Okay, angle dia sama je, 108 juga. Okay, sebab dia symmetry dengan yang atas. Okay, so if you use MATLAB, you will get this kind of root locus. So this is the angle yang 104 tadi, 108 tadi. Dia lengkung sikit. Okay, so this is MATLAB. Okay, mungkin guna untuk part 3. Oh, habis dah. Okay, so dah habis lecture. Before we go to an example, I want to give you take-home quiz. Okay, so take-home quiz, root locus 1 is past year 2018-19. So the submission is 8 AM Monday. Okay, so you can try this. So yang ni legendary jugalah sebab student dia tak dapat reduce, dia tinggal terus, dia tak buat langsung. Okay, so this one involve reduction of block diagram. Okay, so mungkin boleh asah dari sekarang korang punya skill untuk reduction block diagram sebab dekat final ada. And then take home quiz number 2. This is last semester. So this one submit Monday the following week. Okay, 28 hari bulan. So this is last semester. So soalan dia simple je sebenarnya. Sebab dia tak bagi soalan dia tak bagi transfer function, tapi dia bagi poles and zero. So you need to derive your own transfer function. So kena faham konsep forward transfer function tu apa, unity feedback tu apa, kat sini ada unity feedback. And also need to understand what is closed loop transfer function. Okay, so try this question and we will discuss on the following week. Okay, so let's try one example before we end our lecture. Okay, so we have 8 rules. Okay, so these are the rules for sketching the root locus. Okay, so rules dia balik-balik yang ni je. So we will when you want to plot to sketch the root locus, try to follow the rules one by one. Okay. Okay, so let's say you have this forward transfer function. Okay, GS is the forward transfer function given unity feedback. Unity feedback maksudnya, okay, ni forward, and this is your unity feedback. So unity feedback, dia punya value h equals 1. Okay, so when you have unity feedback, you can straight away determine the poles and zeros from GS. Okay, however, if you have a non-unity feedback, you need to simplify the transfer function to get closed loop transfer function first. Okay, so we use rule number 1 and 4 until 4. Apa ni tiba-tiba ni. Okay, so from GS, the poles are S equals 0, minus 2, minus 3, and minus 4. And the zeros are minus 1. So we have 4 poles and 1 zero. So you are going to expect there are 4 branches because you have 4 poles. And here you only have 1 0, so you need to add 3 more zeros at infinity. So infinity, 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 to make sure that the number of poles and zeros are the same. So you need to add infinity. Okay, so you plot the poles and zeros. So poles at 0 here, -2, -3, and -4. And the 0 is at -1. And 3 more zeros at infinity. If you use rule number 1 until 4, you will get the idea that the root locus will start from this 0 here, from this pole here, going to the next 0. Okay, so the other 3 poles, you can go to the 0 -1 here because it's already used by this pole. So the other 3 poles must go to infinity. Okay, kena pergi ke infinity. So the possible sketch that you can get roughly is that this 0 here, this pole here will go to infinity, akan gerak ke belakang. These 2 poles will coincide at each other and then break away. Okay, sebab dia akan pergi ke infinity. So they need to break away and go to positive and negative infinity. Okay, so here you have the breakaway point here. Okay, so we use rule number 5. So rule number 5 basically to find the asymptote. Okay. So finite poles minus finite zero divided by number of poles, number of zero. So the asymptote is at minus 2.6, somewhere here. And then the angle, you get pi over 3, pi, and 5 pi over 3. So at L equals 3, so you get 7 pi over 3. So this is already more than 2 pi, so kita tak nak, okay? So the angle will be, the asymptote will be something like this, and this, and this, okay? Ada 3 asymptote. So the angle is at pi over 3, pi, and 5 pi over 3. Okay, so your root locus is something shown in the slide, okay? So dia akan break away, and then it will increasing and never cross the asymptote and cross the JW axis. And it must be symmetry. Okay, symmetry about the real axis. Okay, this is how to find the JW axis crossing. So to find the JW axis crossing, you need to find the closed loop transfer function first. Okay, and then use the denominator. And substitute in the Raut-Hurwitz table. And then use rho as 1 to get K. Rasanya ada something salah kira kat sini. And then use rho S0, S2, and K to get S. Okay. So this is the value of S, the JW axis crossing. Okay, itu je cara dia. So you can You can try later this example in the slide, okay? Okay, sometimes the question in final, they will give you what we call it guided, okay? Guided means dia suruh cari asymptote, JW exists, and then the value of K. Sometimes the question straight away ask you sketch the root locus tanpa memberitahu nak suruh cari asymptote ke, JW exists crossing ke. Kalau soalan macam tu, macam kena cari semua lah. Okay, so you can try, but we will discuss next week more on this example, okay? Okay, so that's it for today's class. If you have any question, do not hesitate to ask me, okay? So, for quiz, only do the take-home quiz 1 dulu, okay? So that's it for today's class. Thank you very much, and Assalamualaikum and goodbye.
Thank you, Doctor.
Thank you.
Yeah, there.
Thank you.